based upon George Carlin's 7 Deadly Words, said things. But as I said,
the 7 words you can't say on TV.
Yes, that's the thing. So apparently, in the first 7 minutes or 7 seconds, if you were to give Nixon's first name, is he calling
except it's not seconds though; it's minutes, from my understanding.
Minutes, 7 minutes.
They made it long.
It's a thing that is. So I guess that's the demonetizing stuff that you might get.
Yeah, well, I don't know if you've been on my channel ever. Person whom I've literally never met in my entire life, Landon, and I've never spoken to before this time. You might know that. Fuck it.
Yeah, but does that count? Oh no, we're not live yet. So
right, it only counts.
That effort doesn't.
Yeah, it only counts if we go live. Once we're live, once the audio starts.
Or or there's like there's a guy that's buried at Chesh. His name is George Foucault, and it's spelled as you expect, and it's real name. I suspect that what would happen is you would be demonetized and you appeal long after you don't care. That's the usual outcome.
People yesterday during the open hangout were asking if they could swear on my channel, and I'm like, I let the Scotland man in. I think we're probably fine.
Yeah, so he didn't swear as much when I was sort of mentioning Westminster and so forth, but yeah, he did a proper. He was a proper Scot. No true Scotsman fallacy. Oops, we're starting. He was a true Scotsman.
Hello. Oh, it doesn't
Hello.
go away. Hey, yeah, we did. I'm having a little bit of problems in the background. I'm having a little bit of technical issues. I'll figure it out. But hey, welcome back to the Debate Hub. I am your host, the Master Debater. Chesh, and Landon is with me today because we're gonna have an extra Volcano special because Mount Kilauea decided to not quite go boom, but did decide to erupt. Landon, how are you? What's going on?
I'm doing fine. Good morning, good afternoon, or good evening, depending on your time zone, latitude, and volcanic status. Hello to all folks, and it is very interesting, but not surprising that Chesh was almost right.
Yeah, right? Me, the person who knows the least amount, was right, and that's just to tell you like how much this makes no sense.
But it is a case also to show you how difficult it is to try to make prognostications. Now,
is that a word, Landon? Is prognostications a word, or did you just make that up right this second?
I believe it is technically a word, but you could, and am I using it correctly? Well, I could rely on what Humpty Dumpty said, I believe, or was it the caterpillar who said, "Words mean what I say, nothing more, nothing less."
Oh boy.
And Alice said, "But you can't say that." And she says, "Well, the question is, who's the master, you or the word?" So I'm paraphrasing Alice in Wonderland, or Alice.
Why were you arguing with a caterpillar?
Well, actually, Alice in her adventures in Wonderland had lots of discussions with various critters.
Critters. One of them may or may not have been a Cheshire cat.
Yes, and is there any relation? You tell. So it is fun to see how wrong one can be in trying to predict what Madam Pele Volcano did. And in fact, had we had the show just a couple hours later, we would have seen the beginnings of the eruption.
Yeah, we were off by an hour. We could have been live watching and then watched it go definitely not boom. And we didn't. We just missed it because Madam Pele likes to mess with everybody, literally ever.
Yes.
So
in
rude.
Particular, it is well. She has a mind of her own, and in fact, likes to take your prognostication and play with it. So she's a little the technical term. She's a little bit impish, goblinish in that sense of.
We should mention Maanyaa is not with us today. Maanyaa is off in the stars doing who knows what, highly classified research. But she will be back next month.
rumor has it that it has something to do with near event horizons of black holes, but we'll see whether she admits to that coming back.
Yes.
But we wish Maanyaa all success in planning monumentous events around massive.
And thank you, Michael, for becoming a member to the Iron Goblin tier. Welcome, welcome, welcome. I hope you join us in the Discord if you decide to do so. We'll see you in there. You can see Landon making pizza. There.
Oh yes, and other things like that. I did. Sometimes it's a group effort, so we'll have to do more of that. I'm looking, by the way, at getting some kind of camera thing that could be
a GoPro,
on my chest, a type of thing. Yes, to be able to do the live bits of stuff. But that is a planned thing. So anyway, back to the volcano. So looking back, the signs were there that eruption was coming soon. Right? Remember we talked about the deflation inflation event saying it's pretty active, and there was actually a bump, right? And that was the precursor to the magma heading up. So right now, as of this morning, there's a fountain going in the lake. There's actually 2 sections of the lake that are active. We'll see. It's putting out about 3,500 tons of sulfur dioxide per day as of the night. So there's a significant amount of outgassing, right? It was when it began that day. Had we known, we would have seen the amount of gas coming out was extreme, right? That was part of that little spike, and we'll see that in the spot of the magma heading towards the surface because the gas was essentially causing it to boil coming out. So let's look at the deformation here and see what happened. Here's the spike. This is the spike, the precursor of the magma heading its way. We were saying, gee, the magma chamber is still active. All these deflation inflation events, wiggly soft, right? And that was the beginning.
Yeah, that like instant spike up, all the way down, all the way up again.
Yeah, that was the beginning of the break, right, of happening. And it's fairly rapidly doing DI events. If we look at stuff daily events, so it still is quite active going forward. The other significant thing is look at the summit length, right? This is the new summit stuff. You see the summit beginning to contract. This is the length across the summit, right, over the year, and it was going, and we see this little blip coming down, as in there was pressure building up. If you look at the 5-year period, this drop was the end of that 35 and a half year great eruption period, where all that lava came out the end of the island. And it kind of stopped, and so they said not erupting, and then it had a little bit of a blip here for several months, starting there was a day after Christmas, Boxing Day. Went for a while, and it stopped, and then it started again. But instead of stopping, it kept going.
Right.
Expanding. And you look at this spot here, and you say, well, does this mean it's going to contract and go down? Well, it's gone up and down before, so it might be too premature to think that the summit is contracting.
Yeah, and this is specifically Kilauea.
Yes, this is specifically Kilauea. And so but probably the thing as we saw was this spike previously, and that was the sign that something's happening. I had interpreted it as an earthquake. Well, it was an earthquake because the rock was cracking and the magma was ready to go out. So Chesh was almost right. If she had not said boom, she says, I think it's going to erupt, then should have been spot on. So
I overestimated how much of an explosion there would be about it.
You were projecting your goblinness.
My desires. This is what I wanted to happen.
Yes. So here is the map of the current summit, and before, when we would see eruption stuff here, we would see this big little bit of lava lake over here, and that still is going, but there's a couple of spots that the big thing is this other pond around here. So we'll see more of this process going forward.
And I definitely recommend, by the way, people go look at our first video about this, where we went through and explained like how this works and what we're looking at and what a lot of these charts mean during our very first episode. And you can see what this looked like months ago.
Yes. So this whole lava lake area was you see the dashed line. was where the lava that spilled out at the beginning, filled out this area. It was a pretty big outpouring. There, and hopefully we'll find more of that stuff. But right now, you can park here at this visitor overlook or this overlook and look down here and see some pretty spectacular sights. You just fly to Hilo. You get a rental car. I suggest you rent the car first and then buy your tickets to Hilo. A 40-minute drive up, enter the international park, pay entrance fee, and enjoy.
Yeah.
So this is the thermal map showing you what it looks like here.
Do we see Gilligan's Island there?
Yeah, this would be Gilligan's Island right here. But Gilligan's Island got almost covered, right?
It's almost submerged.
There. It may, if this continues, it may eventually, because Gilligan's Island, this whole block here is sort of like a hardening, like a bread crust stuff. And Gilligan's Island seemed to be somewhat anchored to the floor a little bit. It might eventually detach and float, but for right now, it's in danger of drowning.
Michael King sent us a super sticker for 5 that's a pair pumping it. So thank you very much.
Yes, thank you very much for the pair pumping it. Definitely, Pele is pumping out.
Funnier when Landon says it.
So, earthquake-wise,
yes,
there is still this area down here in Pahala. Here's the top of Kilauea Summit. Here's the top of Mauna-loa Summit. So Mauna-loa is relatively quiet. Kilauea has a few earthquakes around the summit, but most of it is these things down here, and these are deep, right? These are deep earthquakes around here. This is the magma rising up from the mantle where it heads to one of several spots. It heads to the, let me unzoom here. It either heads to the seamount here that's a new volcano running, or heads to Kilauea, or heads to Mauna-loa. So that's kind of the state of affairs with that thing. Webcam wise, we look at some web cameras. Here is a current picture of the
spicy.
And so here's the big new flow out here.
Yep.
And in fact, it's got what's called a bathtub ring, right? Lava keeps coming over to this area and kind of stopping, going to the edge, and it has the little Ponscombe stuff there.
You can see the date in the top left corner there. I'm not sure if you guys can see it on the outside. It's 2023-01-13 at 10:50 HST.
Let's see. Oh, here's an update.
Which would be in the AM,
now
by the way, because it's a 24-hour clock.
12. So here's 12:50 HST now.
Yep.
Updated. Here's another spot here. Looking at that. Looking at this spot over here.
There's Cherry Middle.
And so this was at 10:49. So we'll update it again to see. And there it is. Some more. It's kind of fuzzy because there's a lot of heat rising off this. This is all very, very fresh lava. We'll see pictures of it. Here's another picture from looking down on high. And if we redo this thing again, we'll see that, right? So we'll see lots of gas coming out, and that main fountain.
And that's what the blue is. The blue is the gases, right?
Yep.
And do we have a rough idea of which gases those are?
Those would probably be sulfur dioxide, carbon dioxide, and water vapor, plus some other trace.
Like, yo, I heard you wanted to die.
Yeah, not induces the stuff, and hopefully there's enough wind blow it away, because it's sometimes sad to see a bird come down and say, wonder what this is, and they find that they can't breathe, and so they fall down. It's a sad thing. Offerings are there. So here is the thermal camera.
Oh, whoa!
Looking down, and the thermal camera is saturated. I mean, these are the temperatures here.
Right.
They haven't recalibrated the camera temperature, because this is very, very hot lava.
Right.
It's just basically so bright it's saturating the thermal camera.
Plus 140. I would assume that's 140 degrees Celsius, or is this isn't in Kelvin, right?
Yes.
Okay.
Yeah. As also said, it's way higher than that, and it's so bright the camera is having a problem doing that. Need to adjust it. This was a case where the very beginning of stuff, and so you see here that this is plus 500, almost to 600 Kelvin I mean, it's still considered Celsius here.
Right.
And it exceeds that stuff in part because some of the very high temperatures the camera is not sensitive to.
And is that the bathtub ring we're looking at there from
yes,
earlier?
here's usually this bathtub ring bit. This is the other stuff with Gilligan's Island sitting here,
right?
Or what's left of it. But there's other hot spots around, right?
Yes,
This
it's
flow
working
out
its
here,
way. Path of least resistance.
for stuff. Air quality, of course, is kind of suffering. There's this big giant blob here saying gassy bits. Not too bad because there still is some wind, not enough to blow it down here. But normally this area out here gets the volcanic gas. But right now it's not much wind, so it's kind of flying around there. So here is here's a movie showing the very beginning. So here's Gilligan's Island.
Had we been looking,
had we noticed stuff or delayed or dawdled, this is what we would have seen. So wait for it. Wait for it. See, there's a little bit glowy bits. Oh, look. Oh, that's a reasonable boom.
This is not bad. It's not huge, but
look at how high. Again, this is the kilometer across, so this gives you the matter material and how fast this is.
It's fast.
This is real time.
How high did that get?
I mean, this was in the 100-meter plus area for initial crack and bang out the surface. Of course, it kind of around there, but this was the beginning sign of stuff like. And people who were there said there was a nice boom that came about.
Oh yeah. Oh, so there was a boom.
So that was the very beginning of stuff there. So there's a little bit of a boom. Here's from another angle.
Oh. Well, like you can see it kind of spouting a little bit more heavy before it pops.
And I saw a little bit of spouting stuff there, but not to the extent. But theirs.
Oh, very cool.
A lot of nice spiky earthquakes there and rumbly bits.
You can kind of see some of the movement. And like how the air quality just drops like a rock.
Yes. And here's sort of the peak on Gilligan's Island or what's left of it there. So this shows you some of the thing at that night of the flow coming from.
Whoa.
This is showing you sped up. You can see the time, right, going through a day, and you see it's heading through the entire caldera, right? And this was Gilligan's Island. That little bit here is almost drowned.
It's doing its best. It's holding on for dear life.
There's that was a moon setting. It's a sunrise.
9 in the morning.
Mountains about 7 meters of additional material,
little
which says
lava
this
waves.
Thing is actually, isn't that fun?
Well, if you ever wanted to animate lava, anybody, here you go.
Yeah.
Or if you're running your tabletop RPG, that is definitely not Dungeons of Dragons. You can use this as like reference points.
Yeah. There's a sunset and back to. You can see all kinds of sparkly bits there.
Ooh,
for that
shiny.
through the day.
Do enjoy me some shiny.
Yes. See, for the full day. So if you look at some of the set here in early on January on the first day, you see there's actually multiple hot spots. This was that old little spot. There's Gilligan's Island.
Yep.
This is that old little flow that would kind of come up and go down. So all these are new spots here. They're still erupting from these vents, but none of these things are covered, right?
Yep. Yep.
If you look at what's happening here, Volcano Summit. which you're not getting the helicopter noise.
Right.
But there's some, of course, lots of nice cameras, splattery bits. I like these fractal patterns that come out from these things, right? That there are waves coming off this way, but there's also circular patterns, which is why you get these nice jaggedy bits here.
Yeah, it's almost like what's the window? It's stained glass. It's got a stained glass kind of vibe to it.
And this is a very sort of pattern that we see in these lava lakes, is these sort of jaggedy, lightning-like bits.
Fire glow spider web. Yeah, very cool.
Yeah. Here's more stuff of the morning here. So here's nice mauna-loa, which
sunrise.
Is quiet. Sunrise here. You can see the fog and so forth, and the various hotspots here for showing stuff that's happening. More of these sort of summit stuff here with glowy bits. And these are some of the movies we already played.
Yes, we watched movies.
This is live. Here's what it looks like live. This is the current live picture.
It's bubbling away. Ain't like nobody's business.
Yeah. That's
what it looks like every time I try to heat anything up in a pot. It always boils over. Every time I get distracted.
And so all this is fresh lava. This is fresh lava that only has a little bit of ponds.
Yeah, if you think that red part's dangerous, all that dark spot around it is just as hot.
And this stuff here is more, a little bit more plastic sea stuff. But it's also covered by relatively fresh lava. So
it looks like there's a little bit of plumage coming out at the very bottom there too. Right, yeah, there. Here. Yeah, and right to the left a little bit.
There.
Oh, I've got a mouse right here.
Yeah. Oh yeah.
There, right there. It's coming out here.
Yeah.
And all little right over here. It's like a bunch of all little spots.
Yeah.
Coming through.
So last night I took a movie of the camera, right? Because it's better you can see. So let's just watch. This is real-time movie from last night. And we'll see the slow flow, and there's little thingies down here and over here and over here and over here and so forth. It's
so much easier to see at nighttime.
Yeah.
And the time on this is at 20. I'm seeing 2038, so 8:30.
Yeah, but that's Hawaii time.
Yeah.
Which is
HST.
3 hours behind. I think it's 3 hours behind Pacific and 6 hours behind Eastern.
Yeah.
For still late at night, but you can watch these cracks and little things where these waves would come over, and then you get these big splatters that would sometimes go up quite high.
Oh, and you can see the other lava moving around it if you're looking closely enough. I don't know how well it's translating to the outside. I might be able to actually move that in a little bit so you guys can see a little bit better. Come on.
She has the technology.
I do, allegedly.
That's really good. Why are you looking at what it looks like after you eat Taco Bell? Yeah, allegedly.
Sorry, 1 second, I have to get this out of the way. I was futzing around with some other stuff. Ignore that. You didn't see anything. That wasn't anything.
No, we didn't.
You saw nothing.
Nothing to see here.
There's nothing here. There's nothing. This isn't anything. This has nothing to do with production. Don't worry about it. Do not look at the man behind the screen.
Do not watch sausage being made.
You never watch sausage being made. There we go. Okay. Right here. There. Now I can move this in a little bit. So you can kind of see like the little ripples going on there. You can see how it's kind of waggling around all over here.
So there are other spots up in the top center. That area here. So this is one of the hot spots, but that hot spot, this is one of the fountains we saw from previous stuff. But now the lava lake is high enough that it's drowning.
Enhance.
I don't know. Maybe because part of the problem is that the thermal gases is causing fuzzing to occur. You run them. There's a whole bunch of stuff in here. So there are fountains. There are many fountains underneath this set, but some of them are being drowned by the other big thing. And so this is all sort of this again. This is real time last night. A little bit again. It's a little bit easier to see this. And again, if you
sloshing
fly,
around.
if you go to a national park, you can go up to the it's open 24 hours a day. You can go up to the visitor center, look over. You'll see this for yourself.
It kind of looks like city lights all down in here.
Yeah. And occasionally that there's kind of a congealed bathtub ring around it that the material sometimes flows over. So later on it kind of breaks out and floods in this area as it gets above the bathtub rim.
Look, you got mommy and you got a couple little babies.
Yeah.
It gets pretty aggressive in some spots too.
Yeah.
Somebody needs to put googly eyes on it.
It is so looking at this thing, there's not just one fountain. There's a bunch of fountains underneath supplying this material. And one of the things that eruptions typically evolve is that you get so much stuff on top that the stuff kind of interferes with the big fountain, right? So the initial eruption and the very tall fountains began to drown themselves because now the rock has to go up through all of the other stuff. Remember, this lava lake is almost 700 meters deep at the deepest spot.
Right.
But it's starting to kind of turn into pudding, kind of congeal.
Pudding
and so it's pushing up inside, causing it to expand like a bread that's proofing it. But the expansion caused it to break through. Now we're seeing a little of some contraction, which sort of says that the pressure was building up is relieved a little bit. However, we see deflation events of the tilt meter showing there's still a lot of energy coming up through. It's not
right.
It doesn't seem like it's going to stop anytime soon. That being said, just it would be very Pele-like at the end of this show for Pele to say, "Okay, I'm done," and start to drain.
Right. Or go completely opposite direction, or do nothing, or anything goes. There are no rules here. Or there are rules and we just don't know what they are.
Where the eruption ends, the thing comes down, and basically you start to get a bathtub whirlpool starting to swirl around as it goes.
Lava down, whirlpool. Right? Does it change directions depending on what side of the hemisphere it's on?
Probably. Given the size of it, yes, I would think so. Unless it had already had a spin to it.
Right. Sure.
And this is part of why some of these things are jagged bits. There's outflow from these various spots, but there's also a circular pattern going through, which is part of causing these cracks to move.
Yeah, it's moving outwards from kind of a center point, or like the biggest center point, and then you can see kind of where it's cracking in different directions and zigzagging around. It's getting interrupted by other flows.
Sure. It's difficult to photograph again because there's so much heat coming off of it.
Right.
The shimmery fuzzy bits is because thermal stuff, right? It's a
right.
It's only you get moments of clarity if you get a whoosh of wind to blow out the thing and try to cool down the air until the air heats up and becomes all shimmery again.
Very cool. Very cool. I can't believe, right? I mean, I can believe. It's like, of course it erupts right when we're done. Of course it erupts right when we're done our stream about it. What the hell?
So we'll put into because we're looking at the current stuff. We're looking at this pretty loud stuff here. This is the same sort of thing, right? This is what it looks like in the daytime.
Right.
With stuff.
And you can see the same spots, right? You can see the same spots clearly have their little burst outs here and up at the top here. It's just a lot harder to see all the details because it's bright out. The sun is very big.
Yeah, light.
It gives out a lot of light.
Yeah, a lot of light stuff. So the sun kind of shouts there, but the nighttime stuff is pretty good. So I don't think we'll leave this particular link for this live feed here. It's a USGS stuff.
Yes.
And you can click on the like thing to help them stuff because there are unfortunately members of Congress that say we've got to stop all this global warming conspiracy stuff, and so we can't let they need the likes.
Landon sassy today. He's got no time for your nonsense. I mean, to be fair, there's been a lot of nonsense the last couple days.
Yes, some people are professional at nonsense. But look at all these blobs. It is quite. It's quite the thing, and it just is a mesmerizing.
Yeah, there's a lot to. I mean, you've got your lava lamps in the back. I finally got myself a hold of one over there, and it's like
she's got the nice sparkly tornado-y thing.
Oh yeah, I've got the tornado one too. That one's RGB though. Changes colors.
Ooh. Tornado bits.
It's like the Canadian version of a volcano. It's full of snow.
Oh, yeah, very good. And the one that was a goose egg just before we started is now actually doing its loopy things.
Man, mine's a goose egg right now.
But it'll
get there. I believe.
I believe. This one is just erupted back there and it's not broken through. This stuff is just beginning to erupt. So it kind of lava does what it does.
Smitty said, okay, sure, let's stop the conspiracy from corporations who profit off of ignoring global warming. God.
Yes.
You were worried about demonetization before.
And it
coming to get me
is a case that the amount of gas that volcanoes put out is small in comparison to the amount of gas put out by human processes.
Yeah, Gup, we were actually just looking at that. We're just looking at the nighttime one that Landon took from the same place. Smitty also wanted to ask Landon about Canadian volcanoes because there's not a whole ton, but there are a few.
There are a few. In fact, was it 1904 or 1907 was when the last known eruption happened in British Columbia. But it was so remote that people didn't notice it until a number of years afterwards. Apparently, there's a lot of Canada that most Canadians don't know exists.
And don't live in because it's like, nah, I don't know if I like it over there. Seems kind of yikes. There's lots of bears over there.
There's a lot of Canada that's pretty remote. And so this particular eruption, they figured out that there were some, First Nations people that said, the air was kind of bad at one time, but we didn't really know why.
Yeah.
And because their settlements was far away from
right.
But that's the last time. It was 1900s, early 1900s, when the last Canadian volcano erupted.
Jackalope says, my daughter got a tornado lamp for Christmas, and she's obsessed with tornadoes. She gonna be a tornado chaser when she grows up? Because that's a super cool job.
Yes, that is a thing. There's a whole bunch of research being done where they put instruments in front of tornadoes to then record information about the tornadoes. So I would, look. I would certainly study physics.
Yes.
You need some math, and there are a number of schools that specialize in meteorology.
Yes.
And the storm chaser stuff it's kind of the equivalent of the volcano samplers, right?
Yeah.
There are people who know what they're doing, and you can get down personal. But no one goes down here to sample this stuff. We just watch from afar because
there's only so much you can do in a place that's so unpredictable.
Yes, it would not be. And besides, that we don't really need to sample this type of stuff material. There's not a super need for it. We kind of know what's going on in the gases and whatnot. But again, this is just a really nice example of new of stuff happening within the world of.
Don't let her watch Twister.
That's true. I'm looking to see the active volcano counts right now. The number of there are 44 volcanoes erupting on planet Earth right now. So this is one of them.
Yep.
And
many volcanoes go boom.
So I think it's 44. I'm looking at the list of current list as so yeah, volcanoes are we're in a pretty in a pretty wiggly erupty state. So let me look at the current list now. It's probably more accurate.
Yep.
The Europe and Atlantic Ocean have 2, Stromboli and Etna. They're always kind of erupting. In Africa, Indian Ocean, there is 1 in Ethiopia, 1 in the Democratic Republic of Congo that are erupting. I'm talking about active right now. Indonesia has 1, 2, 3, 4, 5, 6. There, I think they lost 1. None in Alaska right now. None in North America. Mexico has 4. No, I'm sorry. Mexico has 1. Guatemala has 2. Nicaragua has 1. In South America, 1 in Colombia, 2 in Ecuador, 1 in Peru, 1 in Chile, central Chile, well, on the coast. Antarctica has 1, Mount Erebus. Of course, it's
so. Which do you think is more destructive currently? If you had to pick one, Mount Kilauea with all of the current erupting volcanoes, or Wizard's current announcement? Which is more on fire?
See, the legends of Madam Pele is that she honors people who are kind to visitors and show that Polynesian hospitality. I don't think Wizards of the Coast understand that. So I think if Pele had an option, she might prefer to send lava through the Wizards of the Coast headquarters than around it.
Burn it all to the ground. Burn it all to the ground.
I'm just suggesting what Pele might do, but
sorry,
again,
I am the one who threw the shade. It's me. I'm the problem. It's okay.
So Kilauea in Hawaii is erupting in Pacific Ocean. Also, Vanuatu has a volcano erupting. The Kamchatka in Russia has 1. The 3 Islands has 1. Japan has 1, 2 that are erupting. So there's a pile of stuff around the, and there's others as well, but that's a pile of stuff. So again, volcanoes are we're on an active, geologically active planet, and
to be clear, we did talk about this before. This is not a global warming problem. Like as in the volcanoes are not causing global warming. The volcanoes are just doing volcano things.
That's a pretty.
Besides, what are we gonna do? Stop volcanoes from doing volcano things? Sure, yeah, we'll get right on that.
Yeah.
Let's make our planet no longer active. I'm sure that would be a fantastic idea. I'm sure that wouldn't just kill us all. I mean, unalive us all.
And it's volcanoes make really nice soil and nice growy bits of their so they're ultimately beneficial after they stop.
Oh yeah, and there's all the underwater volcanoes as well that are either not monitored or we just don't know about. I'm sure there's got to be a handful.
And all those critters that hug around those geothermal vents.
Yep. And all those sharks that swim around there, because there's some sharks that are able to survive in some of those temperatures. Volcano sharks.
and really weird
fire water Pokemon are real.
Critter things on there.
All little critters, little crustacean-y critter boys.
Yes. Now, I just as a public service announcement, I do not
Listen, Pele, I'm gonna need you to sign all these bureaucracy forms, and I'm gonna need you to schedule your next eruption, please. Thank you.
Deregulate volcanoes, yes. Yeah, so I do not. Ooh, that's pretty. Sometimes the fountains get really, really good there on occasion. I do not recommend swimming in this.
No swimming in lava.
If you attempt to try to swim, you kind of like if you threw something on the surface, it would kind of just bounce because it's rock. Right? It's like trying to flop on the beach and swim in the sand. You can kind of do it, but it doesn't really have the same effect as going in the water.
Try to go swimming in Jello. That's really, 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 really hot and has a crusty top.
Yes.
How do you avoid crusty top Jello? I don't know. I don't know if I've ever successfully made Jello that doesn't have like that crusty little line at the top.
Or puddings, right? When I make
puddings have that crust.
Sometimes the crust is actually the yummy bits, right?
Yeah, for pudding, yeah, it works for pudding. Not as well for Jello.
So I don't know what the actual physics are of the actual film on the top of a pudding.
Oh yeah, it's chemistry probably.
Because it's a different texture there. I don't think it's just a matter that it cooled there on top. So I think it almost seems like there's a different texture that's quite yummy.
I'll have to get a baker. We must find a professional because we are people who do not go out of our lane. When we don't know something from a different field, we don't just make random bullshit claims and disparage other fields of science.
Where's the fun in that?
Where's the fun in that? This is a no fun zone. Wee woo. I'm the fun police.
Some people wonder why we don't use fly spray. The mosquito is a clever little bastard.
No.
So questions from the audience, right?
Yeah. Do you guys have any?
I'll flip back to saying live stuff. See, it's still going, still whooping away live stuff. Although notice it seems a little bit longer.
Yeah, and then sometimes it seems like it's being a little bit more aggressive, and it'll calm down a little bit, and then it'll get more aggressive again. Actually, I have a question. How much of this is actually made? Like, how much of that is pressure, and how much of that is earthquake that causes it to kind of sprout up?
Most of this is pressure. There's gases as the magma works its way towards the surface. Pressure drops, and dissolved gases come out of solution, like the carbon dioxide in a fizzy soda, right? The pressure drops, it begins to fizz. So this is the fizz, and that fizz is the loft that takes rock and sends it up, because this rock would like to go down, but the gases, the bubbling stuff of the gases, is forcing it up and out the top. So it's the soda can you shake up and it goes boom up. You're seeing.
Oh, okay.
Now the cycling comes from the fact that the material that comes to the top, it outgasses. Now it's heavy. That stuff starts to sink in and starts to impede the material trying to come up, and so you'll see the flow will start to just calm down a bit until it kind of turns over. New stuff skates around it and comes up the top and goes whoosh again. So it's the fumi fushi stuff, and so you'll see this. See, it's not as active as it is now. Where we go over here,
the Tucker Carlson defense. It's your fault for listening to me because I'm an idiot. Oh no. The legal defense.
It's almost an Alex Jones sort of thing to say, but yeah, it is. It is a case. It is a case where it. So you see this big bunch there. This is now material that's heavy, that's going to impede other stuff coming forward, and kind of comes and goes. There's short cycles and there's longer cycles, right? It's now really going, but in a few moments, it'll kind of there it is, kind of calm down a little bit.
Do you think that that we're gonna see like an eruption that it's gonna settle down, it's gonna come up, and then we're gonna see kind of like a long period eruption like has been in the past, where it's been like this is 30 years long where this volcano was just doing its thing?
It's a really good question.
Yeah,
One
come on,
thing that
chat, keep
perhaps
up with my questions. Let's go.
one thing I could consider is if I go back to the map, right?
Yes.
We say, well, what happened? Remember, we've got this big drop down block, right? And why do we have this pit? It used to be this thing was pretty flat with a small little hole, tiny little hole there. That was Halima Mouth. Why did it fall down and create this sort of like martini glass thing? Because remember, at the very beginning, there was a little lake down the bottom of there.
Yep.
Kind of a little lake, fairly deep. Well, it's because if you go over to this part of the thing, here's the summit.
Yep.
All the magma that was in a magma chamber here underground went down the tube and out and flowed out here. Almost a cubic kilometer came out the end of the island. Well, that cubic kilometer went whoosh, and the top said, "What am I doing standing up in the air?" and fell in.
Right.
Unlike what happens with some of the more cranky volcanoes, let's say in places like Indonesia or Java, those places. This settling was relatively gentle, but it created a pit. So if it hadn't collapsed, what would have happened is this would be a magma chamber inside refilling. We wouldn't have noticed. We wouldn't be able to see this, right?
Right. This will be underground.
We might see little bits of crack of stuff and gas coming up. We might see a little bit of bloopy at the top, but most of this magma coming in here would be under this caldera plate, unavailable for us to see. So this process of sort of collapsing the top allows us to look down into what would normally be a magma chamber. This would be the lower magma chamber, Pele sinuses, that would have operated. And this crater and this crater out here is beginning of this spine. At some point, when this now exposed magma chamber gets high enough, it'll bolt its way into that crack and start draining, or this direction and start draining either to the east or to the southwest.
And again, these are very, very large distances. This is not small. This is massive.
Yes, and like it's like
still smaller than some people's egos, but still very large.
It's I mean, this is the big island, and it's this it's 40 kilometers this way, 20 kilometers that way type of things just for these spines.
And Gup says in 2018 there was a 4.5 mag earthquakes almost daily as the caldera slipped down the hole.
Yes, and that was a fun time. I would say I when I was there, I experienced about a magnitude 5 quake about every 20 hours. It was almost eerie, like clockwork. And sometime I'll go and get some of the videos where you can watch the thing kind of shake and you see the thing kind of drop down a little bit and avalanche bits and so forth. It was wonderful to experience quakes like that, because everything that fell down already been shook, right? And so you just sort of there, ride it out. It's like being on a roller coaster. Whee, right? You just didn't go down there.
Right? Don't go that way.
Pit. But up here at the Volcano House, it was just nice and wiggly. You just think, oh, there's a thing. And in fact, you'd wait until you'd had the quake, and then you go over to sort of see what happened and come back. But yes, that was a period of time. At the end, the draining event was extraordinary. It was short of the great event that happened in 1790. It was the most dramatic summit change we've ever seen in recorded history. The 1790 quake, by the way, 1790 explosive event where Pele got really cranky, created this caldera. It blew out. This used to be a nice smooth top, kind of mauna-loa like, and this area down here used to be about 4 times as deep as it is now. Over the 1800s, late 1800s, 1900s, this sort of filled in. So at some point, this is going to fill in. The question is, how high can this go before it starts melting its way into those tubes again?
Yeah.
And the other problem is that this lake now it's quite deep, right? So it's risen 6 meters since the beginning of the eruption. So not just here, but this overall, it's like a bread poofing up, right? It's risen 6 meters. The the active lake here is about 18 hectares. That's 44 acres. The full area here, this dotted line that spilled out, was 118 hectares or 282 acres. And the lava volume in this lake is now 8.4 million cubic meters, or about 2.2 billion gallons of lava. So normally this would have been underground. This would be a magma chamber, and we would have seen the tilt meters expanding the rock. Right, they have cracks and stuff coming through it, but we have a really rare opportunity of watching what effectively is a magma chamber. At some point, it's going to do something different. It's going to erupt in a normal fashion. But right now, it's just down there in the lake, being a nice tourist attraction, nice and gentle. But the problem on the other side is that as you get more and more lava sitting here, it becomes more and more of a barrier for it to erupt. Remember, it was coming over to this little lake here near Gilligan's Island.
Right.
It was coming to this spot here. That still is erupting, but basically it said it's too difficult to come out here, and it starts coming up here, and here, and so forth. So we look here, you can see Gilligan's Island is a little bit over here. There's a little tip going forward. Yeah, see that spot right here in the edge? There's a little bit of an island still there, but it's pretty close to being covered. There's interesting bits here. So other questions from
Red Eye made it. Oh, chat has been arguing about climate change.
Okay.
They're having a whole other conversation completely unrelated. Well, it's not. That's to be fair. In their defense, it is not unrelated. I started it, and now they're arguing. So we're gonna have a conversation about climate change. I say we. I mean, the channel is gonna have a climate change conversation. We'll have to have a debate hub topic.
So
get a meteorologist on here.
Being online, you talk about given the set here, we can see what Mauna-Loa is doing. This is from talking about Mauna-Loa Observatory. So this is not the telescopes. This is on the big island. There's a gas measuring system that's been going on since before 1960, and you have the seasonal bits, but you can see this parts per million going up, right? And the other thing as well is this is a fairly well calibrated system. They save chunks of gas in containers. We go back to those containers and resample it to verify the accuracy and precision of this stuff. So this line is very, very, very solid. We're out in the middle of the ocean. You're not having sits there. They for example avoid taking samples when the trade winds are putting volcanic gas over it. So they're doing it when it's not on volcanic gas times, and all the stuff they continually resample and check the old readings.
And it's just on like a consistent upwards tilt. Why is it just constantly upwards?
Well, because it went from 320 now to 420 parts per million.
I know how to read the chart, Landon.
I'm sorry, but I'm just giving people who are listening.
I know. Sorry.
This is showing. That the concentration in the atmosphere has risen.
Yes.
Right. It's been just since 1960. It's up 31%.
Right.
Greenhouse gases this is one of the more gentle greenhouse gases, have increased in our atmosphere by 31% since 1960.
From 320 to 420. Pew pew.
Yes.
Pew pew to 420.
And so
obligated.
And so the science denying that the atmosphere is changing is about as pitiful as denying the Earth is round or denying the age of the Earth. Right? It's. I think there's a political question, and therefore what, right? But the data is here, right? And this is a problem that there are certain people that want to be denying the atmosphere is changing, climate is changing. Get mad at places like NOAA, get mad at places like USGS. We're just reporting data, but this is probably the most solid thing of the atmosphere is changing, and we can go back and sample those things, and it's solid, right?
Yeah,
this wiggly up and
it's
down
very consistent.
Is a seasonal thing. There's a seasonal bits there for the seasonal, but that is continuing and it's accelerating. And this is, what does this mean? Well, it means that the atmosphere is getting more energetic. We're trapping more energy in the atmosphere, and we're getting more extremes. We're getting hotter highs and colder lows. We're getting wetter monsoons, drier droughts.
And I mean, I guess that
behavior.
I guess that brings into question, like, if you're gonna, who's responsible for it, or like how it happened is important to try to rectify the problem. But if we recognize that these are data points, no matter what we decide to put blame on, or what culmination of things we put blame on, what does this data tell us? Why does it matter? And what do we do about it?
Yes. And that's a public policy debate. That's a political debate as to, and therefore what, right?
Right. And so what do we do? Right.
Yeah. You don't want to sit there and say, oh, it's not happening, right? You say,
you have to acknowledge that it's happening, period. Whether you think it's because of people, or whether you think it's because of volcanoes, or whatever you're right or wrong about, and to what degree you're technically right or wrong about, depending on where you're looking and at what time period. Like it or not, the number is the number, period.
Right. So sometimes it's just, oh, look at this down here. This is now, this down at the bottom here is now.
It's coming towards us. It's coming to get us.
It's escaped the bathtub ring.
It's making its way downtown.
Yes. And sort of getting the level. So that's the thing that is, I say climate deniers are people that try to discount the data, and they run up against facts, right? That graph is a fact. What they should be doing instead is arguing over, and therefore what should we do about it?
Yeah, right.
That's a policy. That's not a scientific debate. That's a public policy question. That's where
and science should inform your debates, because you can't deny that it's happening. So you need that science, you need that data, you need those social studies to understand how people are receiving the data and how they're understanding the data, so that way you can inform people of the data in a way that they're going to be able to understand, which would then make them able to make informed decisions in politics about how they want to move forward with handling the situation. Oh, you're not keeping your mod rooms. I'm just teasing. I'm gonna make you a mod for now, so you can post your link for your discussion, and then I'll clean them up after. I keep my mods pretty narrow, just because I like having a low number.
Yeah, if you want to look at what it looks like on a couple year basis, I mean, this is sort of the typical graph you see. There's seasonal variations.
Yep.
This is the average
with an upward trend. Yep.
Yep. That's sort of and that's a fairly normal thing. So all these dots are samples,
right?
And they can go back through and calibrate and verify it. So yeah, there's a longer term graph for stuff where we can go back to Antarctic core and see the things, but
right.
So global warming is a really bad term or improper term. I call it climate forcing. We're forcing climate. Look at this nice little flow out here.
I like this little bit over on the, there's a bit over here that's kind of inchworming around.
Oh yeah. Oh yes. And in fact, sometimes it seems like those cracks come over a fountain, a sub lake fountain, and give a little bit of a like here. Yeah.
Yeah.
There's some little fountain underneath that the crack comes over, and it makes it easy for it to be seen on top. And this pouring out here is pretty good. So given where this is, let's look at the current time now to see, can we see where that is? Yeah, it would be, it's this stuff here. See this?
Yep.
See these oozy bits? This is lava that the bathtub ring kind of broke through.
Yep. Like a little dam.
So that's a little bit of stuff again, showing the I like that little, you call it a caterpillar line?
Yeah.
Oh, there's things here you can see on occasion.
Yeah.
Just as memorized. So yeah, back to say that so the climate forcing is really a matter of making our atmosphere is becoming more energetic. The sun is still shining down and heating the ground. The ground radiates heat up, but because of increased gases in the atmosphere,
right,
the heat is trapped like a blanket. So there's more energy in the atmosphere to do more tornadoes, hurricanes and typhoons, longer, later, shorter, more extreme, more stuff.
Right. I mean, you gotta think that though, even just like from the data we had to the data we're getting now, to the point that we're actively watching from hundreds, some thousands miles away, an active volcano from the top. It's not like we have to look at the aftermath and find out what and try and work backwards. We're actively looking at what was going on ahead of time and what's going on currently, because we can watch this live now because we have the technology to do so.
Yeah, they set up a.
I've never seen an eruption before.
They set up a feed. You know, use Akamai. They set up a feed where there's a single feed that goes to the mainland, and from there it gets distributed, because everyone tries to go to the camera at the same time.
Right. Yeah. Leaving D&D Beyond en masse, crashing the websites to the point that they had to try to move the unsub to make it more difficult to do. What a bunch of weenies.
Wow. Some of those spots, it gets to be, and it's fun to see these cycles, right, of energetic versus energetic. So back to the atmosphere. So other, there's lots of other effects that can be seen.
Yeah.
And lots of other data points, correlation of surface temperatures and rainfall stuff and conditions in the ocean and so forth, that also point to the same thing of things being more energetic and more extreme. And so look what happened. Again, California is a perfect example where they had extraordinary severe drought, followed by torrential downpours and flooding.
Right.
The atmosphere. As a friend of mine likes to say, we broke the planet.
Oh, humans excel at breaking things.
and it is true. You can go back into geological history and infer that we've had more extreme CO2 concentrations in the past, right?
Red Eye's trying to bully you and wants me to ask you where you were when St. Helens went boom.
I was next to Mount St. Helens. It was a nice wiggly wobbly thing. It was the south. It was the southwest, about a 1.2 kilometers. With a special suit on behind a ridge line, waiting for it to go boom. And like here, right, the thing you can't appreciate is the sound, right? Being there and overlook and hearing this rock coming up all the way through and splattering up and splashing down is not a little gentle river trickle, right? This is quite energetic. Those are big rocks being thrown up in the air and coming crashing down.
You said that there were people in, I can't remember where you said it was, but they suffered hearing loss because the explosion was so loud. The shockwave was so loud. That was the ocean one, Tonga, right?
Yeah, that was, and that was a case where our weather station up here next to British Columbia heard the sound wave travel around the world 3 times. It was so loud, it went around the world, circled 3 times, and we saw the pressure wave, three different passes from the thing coming from both directions. And so it was one of the, and people in Alaska reported hearing, booms and so forth. We're wondering what was going on. Lots of, call to police stations.
Yeah.
Being concerned about stuff. It was certainly one of the loudest sounds that's been recorded.
Yeah.
And there, unfortunately, lots of people, had hearing damage or stuff.
Yeah.
It certainly and certainly has dwarfed some of the other things. There have been other sounds, man-made sounds as well, like the
one lady who can like scream
explosion.
at some kind of the Halifax explosion. That Jesus Christ, I need to really like go because I was following it at the time, and then life happened, and I wasn't able to like see if they reached a conclusion about everything that had gone on with it because there was some sketchy shit going on. Like, why the hell did this happen?
Yeah, there's some dumb things that happened.
Yeah,
as well.
Some mistakes.
But yeah, if you don't know about, look up the Halifax explosion. There's actually a museum there. But the number of people that were blinded or deafened or both was quite extraordinary. And it did there was a profound improvement for services for the disabled.
Good.
As a result, because there were so many people in Halifax that were essentially had injuries of that nature.
Yep, and sometimes people don't care until it happens to them. Now, when your population is the majority hearing impaired, they're suddenly really going to care about hearing accessibility.
Yeah. Sad thing about that is, on the other side of the coin, is that there are some First Nations people that lived in an area that cleared out, and people said, "Oh, well, thank you very much. We'll take your land."
Yikes.
But that's nothing.
That's a conversation. Anyway, that's a conversation for the tavern.
Go and look at the Halifax explosion, the largest non-nuclear explosions ever recorded.
Yep.
Anyway, back to this stuff. These are, but volcanoes are nice and relatively gentle in this setting, right? Other volcanoes can be quite cranky, and Tonga was a cranky volcano. But again, it's extraordinary you can get this close to active eruption. And remember, again, we're seeing effectively a magma chamber exposed. We're looking inside the magma chamber as it's slowly filling up.
Yep.
I predict at some point down the road, that whole pit will get high enough that it'll begin to melt its way into one or both of the spines. And we'll get a drain event as it starts to do its normal thing.
I think that makes sense. I expect, like, it seems to make sense to me that now what we're looking at is something underground has attached itself or has pushed itself upwards, and now we're looking at the filling. And once it gets to the top, once it crests, it's just gonna bust through, and it'll be moving real fast.
Yeah. Little loopy spot over here. There's that caterpillar line there. There's a little blue spot over there. A little spot over there.
Yep.
Lots of a little spot over there too.
We were already looking at some stuff going over that bathtub ring, and the bathtub ring is just minor compared to like the overarching sort of dam all the way around.
Yeah. And so this overall pit has moved up about 7 meters since the beginning of this eruption, just after our show. So a lot of the volume expansion is coming from inside, right? Most volcanoes grow from inside. They don't go on top. This on top stuff is relatively minor part of the volume. Most of it is coming inside, like a blister pushing up.
Yep.
It's only, and probably the reason why this stuff is that the pushing up got so big that the top cracked and creates a weak point where it comes out. Yeah. So what do you think the volcanic eruption is going to be like
for the next time
we have our normal show? What's our normal? The normal show is
February 10th, I think. Let me double check. Oh, hold on. I got notifications. Go away. Stop talking to me. I'm live. Leave me alone.
Or let's see.
It might be the 4th. Hold on. I've got it up. I've just got it. I just have to wait for my calendar. Volcanoes 3rd.
No, it's the 3rd. The 3rd.
3rd of February.
Let
me be your
13:01
Valentine
p.m. Pacific.
volcano.
Yes. So what do we think is going to happen by the 3rd? That's 1, 2, 3 weeks from now. What do you think?
I think what we're probably going to see is a little bit more consistency. I think it's going to wobble a little bit, but I think it's going to be consistent, like at this rate for a little while. That would be my guess.
And I think what we might end up happening is that rather than having big, thick fountains here, the lake level is going to be so high that it'll just be a bubbly spot.
It'll be a bubbly spot
so
over, and it'll come out the bathtub ring.
Yeah.
Yeah.
We might even have a pretty good bathtub ring surrounding the lake set.
I'm curious to know that if and when this drains, will Gilligan's Island still be there?
Yeah, because I think Gilligan's Island has pretty much submerged. Let's look at the set. So this was I want to look at the live set here. So when I look, and let me redo this. So here's the spot. The Gilligan's Island is over on this side. So we need the other view.
Yeah, and Red Eye says, see the fountain? We estimate the little fucker is about the size of an Olympic swimming pool.
Yes, it is. It is putting out swimming pools versus lava. That's the stuff that's on top, right? This whole area you're seeing right now is really soft lava, right?
Yep.
And it is growing from inside. Most of the expansion is inside.
Yeah.
Coming from inside, pushing up. And this is not Gilligan's Island anymore. Gilligan's Island was over in this area here, and I'm not seeing it. I think from when it was doing where is it? When it was doing this stuff, right?
Yeah.
You saw
that corner right there. There's one spot right there.
Yeah.
Poking up.
But this is it's subsequently sort of flooded. So Gilligan's Island may be submerged
currently, yeah,
right now.
And so,
but it might pop up.
We do also have a question from Michael in the chat that said, "What's the scope for supervolcanoes, like from a time frame stamp? So when do you estimate the next supervolcano could or would happen?"
Well, generally supervolcanoes come when you have a large caldera that has been erupting a long time, has outflow, so much outflow from eruptions that the top caves in.
Right.
Volcanoes typically are dangerous when they fall in. The Hunga-Tonga eruption was the top of the magma chamber fell in, and all of a sudden you have this ocean sitting on top of a magma chamber, and the two
exploded.
Went boom.
Now, would that be was Tonga considered a supervolcano?
No, it's not. Usually it's a larger plume like Long Valley, or there was a thing in New Zealand. Of course, the History Channel does Yellowstone every once in a while. But in order for that kind of event to occur, you need to have a large caldera cap erupting by side volcanoes, and then the thing falls in and goes.
So we don't
big boom. Right?
We don't have that right now. We're not seeing those conditions yet.
Yeah, there certainly are other areas that are probably geologically more likely to have a supervolcano event.
Oh, apparently on the live, the KW cam, you can actually see the island right now.
Oh, over here? Is it that spot? Let me. Is it this spot over here?
Oh, peeking up.
There's something really there, but yeah, it's not very big. If it's holding on, it's got it's a pretty tenuous spot. But yeah, we saw this spot there. In
Yellowstone's not going to erupt for a very, very long time outside of extenuating circumstances that we don't know about.
Yeah, I mean, it's got to, in order for Yellowstone to do its thing, and and again, it's probably on the order of tens of thousands of years, it needs to begin erupting in the first place. That color needs to fill up. And if you look at,
oh, he's saying, sorry, Gup is saying to look at the camera, not the live feed. Sorry, that was probably my mistake.
Look at the camera.
The summit webcams.
Okay, so summit webcams is over here, and probably here. There we go.
Hey.
There it is. All right, there we go.
Little buddy.
There's
Gilligan's Island is still peeking up.
Yep, there it is. Now, it depends on, the question is how anchored is Gilligan's Island to the bottom? Is it stuck?
And will it melt?
Or is it going to be floating?
Yeah.
Because here's the old, this was the old spot when we were to look at, months ago, we'd see little bits of stuff. This is and this lava lake is still going. This is the big, this is here. And this thing flooded all the way to the edge, but this is kind of the big ponding in this area now.
And you can kind of see that bathtub ring there.
Yeah. When you look at the history of volcanic eruptions with Big Boom, right? Mm-hmm. Volcano Explosive Index, VEI, and VEI 8 stuff. These are various things that occurred. Over here is probably the last mega colossal, lots of stuff.
Ultra mega humongo gigantus.
Yes. It put out several megapints worth of lava.
Get me with the megapints every time. Michael King for 5 says, thanks for asking. I thought Yellowstone had a lot of tremors recently.
Yeah, it's a volcanically active area, right?
Yeah, it's active, but like a giant eruption. Those are two different
last eruption is about 630,000 years ago, which formed the caldera. It's collapsed, so that caldera has to refill, do how you think about it on a big scale, and then it's got to erupt so much that it falls in on it.
Is it likely that we'll see from like if we were alive, assuming we could jump forward in time and look at Yellowstone, seeing that caldera filling, is that something we would actually be able to see? Or is that something that you'd have to measure over a very long period of time and just see an upward trend for?
I think you certainly would experience it as first of all, lots of earthquakes. The geysers would be severely interrupted, and the water would, of course, start boiling away, and you probably would have surface eruptions coming from as the thing begins to fill. Right?
So we'd see like a bigger version of what we're looking at right now. That's a little bit more widespread, so it'd be like thinner rather than like a lollipop. Yeah.
And so these things, in the scale index of stuff, that some of these things, like the Hunga eruption was a VE5. Some people say it's a VE6 in terms of size. At level of Krakatoa.
Yep.
Probably this one, Tamboro in Indonesia was in 1815 was probably the most massive eruption in recent history. These other ones here are things like Yellowstone did about 630,000 years ago. Yes, right.
So if Yellowstone did go up, what are we looking at? A human's probably not around anymore, first off.
Yeah, but I mean, there's another one in Utah. This Wawa Springs was a huge, in one of these mega colossal eruptions in Utah.
Yeah, I know we talked about Yellowstone before, like 2 streams ago, I think. But out of curiosity, where do you think in the future Yellowstone would fall?
Here's Kilauea.
Way down
there. Down at the 0.
Yeah, little baby.
It's little cute thing.
Little baby.
Frequency constant.
Where in this index do you think Yellowstone would fall? Would it still fall on that upper echelon end, and like, or would it be?
Well, super volcanoes typically when they
they're
collapse.
inherently that way. Okay.
That this size, and some of these things are. I mean, Maanyaa, that form Crater Lake, beautiful place to go. By the way, I highly recommend it. Approach that sort of supervolcano thing a little. It was a more pointy peak, so it didn't have quite the caldera that would normally fill. So it didn't have quite the oomph. Long Valley is probably now one of the world's largest calderas right now, and it is quite seismically active in magma. Jason Mammoth Mountain is moving up inside. Caldera is actually bigger, so that likely when Long Valley caldera in California, Eastern California goes, it'll be in this 8th level of stuff. But again, that's many thousands of years from now. At least, and again, these kind of things happen about every 50,000 years or so. It's kind of the typical rate over time.
Ernie for 5 says, this is fascinating, and thank you, and thanks to Landon as well. Thank you so much.
Oh, thank you very much. Thank you very much for your donating to 5, because it's important to support your local goblin.
Do you think that, because we're on supervolcanoes, how much damage, like assuming humans are still around and assuming countries still exist as we know them, how much damage would be done to like what's the word I'm looking for? The continent that is North America?
I mean, the big thing about supervolcanoes is that their damage is, first of all, by tremendous amount of ash that covers. So you'd have croplands and areas that would get buried in enormous amounts of ash, right? The second thing, of course, is they put out lots of gas and will impact the climate.
Yep.
Right. And so they will have an impact on the climate that is quite severe. So in addition to
long reaching,
piling meters of ash all over the place, that makes it hard for things, kills lots of stuff. It puts a lot of stuff in the atmosphere that causes a temporary cooling that comes back with a vengeance on the other side. So you get a temporary sort of drop and rise again. Here's a picture showing the Long Valley caldera. Again, you can see scale of size of stuff.
Yeah.
Huge areas. And so this partially molten magma, you got to get more stuff coming in to start to build up, and you would see this begin to puff up. And as it puffs up, like we have going on with Kilauea right now, it's
Kilauea, you can almost look at and say this is a very, very, very small version in a very, very condensed amount of time what you would see in a supervolcano. But in a supervolcano, it's expansive over incredibly large periods of time, and where the damage that you can see happening in the area of Kilauea expanded over, again, a longer period. You got to scale everything up.
Yeah, and but this sort of thing, you'd see these flows coming like this.
Yeah.
Well before it has its collapse.
Oh yeah, we'd have a lot of notice for sure. Yeah.
And so it becomes, part of the problem is it becomes its devastation comes from huge ash falls plus the set of stuff. Now we've had lots of these sort of huge eruption sets from there, like happen in India, and we have these sort of areas.
With tectonic
Africa's got a
plates,
bunch, Asia.
With tectonic movement, would that part of America even be in the same spot by the time?
And that's a good thing. It's because the continent's gonna move. The hotspot and it's not clear how much the hotspot will move itself. It's down deeper, but there's some relative motion you'd experience.
But like what we see with Hawaii.
Yeah, for things, for that going on. Let's go back to the live thing here. What we find with these eruptions, right? In terms of these super eruptions, is that you get, and the most recent one about 75,000 years ago, you get, for example, did you know that New Brunswick, Canada, had a 460 million years ago an enormous volcanic eruption? Canada, yes, Canada had a pretty big.
It would be New Brunswick.
I'll say it probably the largest known super eruption.
Yep.
It might have had over a number of
2,000
years,
plus
but
kilometers cubed. That's a lot.
Of objective stuff, right? And that
It's big.
piles up in the spots and makes things not very nice.
Yeah.
Yellowstone is down there somewhere in the kind of middle here, Yellowstone.
I like how I'm looking out my window and it's been snowing almost consistently since yesterday, about a little before midday yesterday. And it's had like a couple of little breaks, but my computer in the corner keeps trying to alert me that snow to stop. I don't believe you.
It's temporarily, it's trying to entice you outside.
I was outside. There was big snowflakes. There was big like cluster snowflakes that were like this big yesterday. And when it wasn't windy, I went out for a walk with the dog and it was super nice out because like it was cool, but it wasn't windy and like icy feeling, and it was a little bit wet. But other than that, it was actually really nice. And Michael sent us a big old thumbs up.
Oh, thank you for the 3 English
pounds
units.
English units. Careful about that.
Thank you very much.
You get yourself in trouble.
It's meant to be endearing.
Thank you for the English sausages.
Yes. So back to say with the do you put out like the sugary syrup thing onto the frozen ground and do that eating of the? Have you done that?
No, it hasn't quite been cold enough to pull it off yet. So the snow that was coming down, the reason it was coming down in big clusters was because everything was really wet. So it was kind of only snow in shape and form for not too long. It's kind of icy outside right now, like on the roads. But once it gets cold enough, we'll see if it gets cold enough where I'm at. What I used to do is my dad used to have a cottage that he owned way up north near up by Tobermory. And so I would go there in February because it would just be like nobody'd be there. Everything would be covered in so much ice. And it was like out by Georgian Bay. So you would see those like big, huge waves coming up onto like giant, like higher than a house piles of ice that's coming off the Great Lake there, because that's Lake Huron. Yeah, it's a whole lot of fun. And then I would just let Puck out and he would just go run around, and then he'd try and go swimming because he's an idiot.
Did Puck realize when you start swimming that it was a bad idea?
No.
Back out, or?
No, he was a fan of it. He was like, nah, I love this. This is great. Luckily, he was not in any danger because the ice is solid enough that it didn't form a problem. It was mostly just some puddles, luckily for me.
I love with this stuff here. You can see the ripples, the waves from the bouncy stuff.
And it looks like it's still moving, although a lot slower. And like it's a little bit hard to see the movement between like the heat and gas waving, right? Like messing with it. But it does look like it's moving very, very slowly. Slowly is relative.
Put a cursor on that spot, it just starts to drift. You can see.
Yeah, it's going.
Put a cursor on it.
Yep.
It's oozing and doing.
Here, I will.
Stuff. So other questions that people have about.
Glad Yellowstone is named Yellowstone because it has Yellowstones. Puck wants to go out and play in the snow and make yellow snow. Yes, correct. Did I listen to retro snow level music? Like snow level, like from video games? So like the icy levels and stuff like that? I haven't in a while, but I should go do that. Landon, do you listen to like retro-y themed music?
Yeah, sometimes I'm very, very retro. I was earlier today listening to early Baroque music, which has sort of the ancient instruments that are there, like 1800 type stuff. It has very interesting sort of cadence. It has little bits of that kind of Gregorian chant stuff, but switching over towards evolving into Bach was the sort of the end of the high Baroque period. This is sort of the emerging of that stuff around the time that Shakespeare was doing his thing, and so you probably would have gone to a theater where playwrights were doing all kinds of interesting things, and you probably would have heard outside the theater musicians playing this kind of music.
I am the dingleberry that will run around and sing Christmas songs well after Christmas.
Very good.
Sorry, not sorry.
And you don't have to do. See, she doesn't have to do the trademark Canada.
I don't have to do the TM.
Canadian.
Yep, it's on my birth certificate. I'm in the clear.
Yes, you get the right to say sorry, but you have to do it properly.
Yes. So we have
because
go ahead.
Go ahead.
No.
So back to say, so we were going to say, what do we think is going to happen in 3 weeks? My guess is it will still be erupting, although it'd be kind of the gas output will be much less. It might have pause times where it pauses for a bit, and it might have trouble breaking through the surface.
Yeah, I think it's going to keep going underneath, but it's not going to always be able to break out
and whoosh around like this. With there might be a little pond here that is kind of keeps going if this vent is still able to push up through.
Yep.
But it would not be surprised if 3 weeks we can spot glowy bits, but not as exciting glowy bits. But that's my guess. And why would I say that? Well, I don't know, and I'm willing to make a thing. But this, as long as these deflation innovation DI events keep going forward,
nobody truly knows. Nobody.
That's going to go now. You might say, "Well, look, it didn't do it very much there." Yeah, it kind of comes and goes.
Yep.
But if it still is wiggly like this, then there will be an impetus for stuff to come up. We might have a little pond here.
The pond might expand. The pond might get a little smaller. It might disappear for a day or so and then pop back up again.
It might get a nice bath as it kind of the pond kind of go ups and goes. We might have towards the edge of this thing this little this bathtub ring, right?
You can see cracks.
This beginning of the bathtub ring here of things, little spill outs depending on if it comes and goes. One of the questions debate right now is: did Kilauea stop erupting and to start a new one, or is just a phase of the previous?
We need to ask. I'm going to start a poll. Did Kilauea go boom? Does this qualify? Does this qualify as a boom?
Yes. Now, I have to say that this, this sort of thing, that's a pretty big. Now, it didn't go boom like on St. Helens boom. The amount of ash that came into the air is definitely VEI 0 stuff.
Yeah, it's very low on the chart for sure. But how big are we expecting it to ever be on the chart in any amount of time?
I mean, in the years,
relative.
In the years for relative explosions, I mean, Kilauea's had a 1790 it had a fairly big boom.
Yes.
But it doesn't seem to be at a stage where it's got much stuff to be able to block itself to build up pressure and go pop, right? It seems to be much more gentle.
Yeah.
So that's my guess. Right? What do you think?
I think it would be really fun. I think that you're correct, but just because I'm a weenie, I think we're going to see something pop out the side.
Oh, you think it's going to be there's going to be something? There's going to be lava coming out by the side, meaning we're talking about, where is the map?
Yeah, so instead of like what it's doing here, it's going to start doing it off the side and just kind of make its way down.
So we might see earthquakes where it comes out one side or the other, and we get a lava event, not the summit.
Yeah.
Well, that would be a dramatic.
Yes.
That would be impressive. That would be a dramatic.
That's what I'm going for.
Change of pace, and I could see that. Given the history of the volcano, it's going to do that eventually.
Yes.
It's not going to always go to the spot.
Yeah. It's not unfounded.
Normally, we might see the beginnings of that if you go back. If you look at the earthquakes that occur, right? Let's go in here. Let's.
Sorry, I thought I heard a ding. I'm hearing things. I'm going crazy. Right? Oh, it was my phone.
We would see earthquakes going this way or this way, perhaps, as because those tubes are kind of crusted over. They got it's got arteriosclerosis, right?
Yep.
And it's got to force its way through, so it's going to be a bit cracky in that spot. We would also expect to see, if it was moving, that this stuff, if there was ponds that are big, would go down. We would see the I would expect.
Yep.
Of course, if it happened, that this thing would drop. Right. This drop is the magma moving down to the end of the island, coming out. Whoosh, right. This is that's the spot that we would expect to be. So if it went out, it may not be that dramatic, but
you might need to move your whatever you're showing over to the other screen.
Over screen. Is it not?
I'm still looking at the Gilligan's Island eruptive area. Oh, that's the chart.
Okay, is it catching up?
Oh, I see your mouse.
Maybe. Is it?
Yeah, we're looking at the chart
showing now. Okay, so this drop was as the eruption was ending, right? This was the drain event that caused all that, which is all the lava coming out the end, right?
Yep.
And this little bit here is where it kind of finished falling down. The lid fell in.
Right.
There's a little bit of fall in here, a little bit of fall in here, but I would expect if it if it was beginning to go elsewhere, that the pressure,
we'll see a pressure drop
top would cause it to sink.
Yeah.
You would expect that to happen. But not necessarily. And so, is this the beginning of stuff? Well, that may be just a matter of one of these little loops here, right?
Yep.
You have to wait and see what would happen. So I would not be surprised if what happened was that this thing bottoms out and starts to go up again. That this is a blip, like one of these spots out here, not a big plunge. But so if what you are suggesting is right, that lava, you're suggesting that in 3 weeks we will see lava not at the summit but someplace else on the mountain.
Yes.
That would be a spectacular thing to happen. So we'll see.
It'll be fun. The poll has come back.
Kilauea could decide, oh, I'm done. Let me go on.
Yeah, I could actually just completely stop. We did finish our poll. 57% said yes, this counts as a boom, and 42% says no, this doesn't count as a boom. So by the fallacy of ad populum of a stupid Twitter poll, I was right.
Chesh is right, and so Chesh wins the Volcano Award.
I win the Volcano Award. I got my new lava lamp to prove it. See, look at that. Look at that over there. It's bubbling away.
There you go.
It's all actually just at the top right now. It's not even ready to finish bubbling. We should probably start wrapping up, though. Thank you, Landon, so much for joining us. This was a lot of fun.
Again, a pleasure to see the top of a magma chamber blooping away and oozing away. And also, it's a nice pleasure that she's not really bothering anyone. She's putting on a show. And
Maanyaa, I believe, will be back for the 3rd. Maybe? Maanyaa might be back for the next one.
Maybe.
She might not be back for the next one. If she's not back for the next one, you can catch her on the soon. Tomorrow to read through Wizards' official information release about what's gone on and what they're saying now. But I'm waiting for tomorrow because I'm getting a little bit tired. So I have to. Hot mess dumpster fire.
So Wizard of the Coast announcement stuff read on the 14th, and then you have something on the 17th. What's happening on the 17th?
What is happening on the 17th? Is that next Friday?
I think it said next.
Conversation or a video that has been put forth about let me just pull it up here so you know what I'm talking about. This guy has made a video debunking their level of success in their debunk and I see how that goes. Because I mean I've been critical of Arn in the past, and I like criticism to be fair and reasonable. Doesn't mean I don't like somebody. And then on
some people are critical of that opinion.
Yes. And on Friday it's gonna be hella fun. We got Jesse and Laura coming, and we're hella good. This one's gonna be fun. I promise you, this one's going to be so much fun. So please come and join us for that one. It's gonna be a good time. There may tomorrow, and we'll see you again as well on Tuesday. Go ahead, Landon.
And there certainly is there's a kind of current events show coming up as well.
Yes.
Isn't there? Don't we have a unnamed tavern?
We have a tavern. There is a tavern. One on the 28th in January.
Yeah.
So not this Saturday,
that's right.
Not next Saturday. The Saturday after, there will be an unnamed tavern, and Maanyaa will be away for that one. And I am picking out who is potentially going to.
Class on relativity up in Canada.
That's so exciting.
It'll be interesting to see, based upon the class that I got from Feynman. It's more condensed, but it'll be because the subject is so deep, you don't want to deep dive into minutia. I want to give them sort of a broad picture of stuff, because I'm hoping what this will do will inspire some of the kids to be interested in fundamental physics.
Live streams faster than you can watch them, because there is a lot going on, and I booked everything this month because I am a fool. This is my own.
Well, thank you again.
Mistakes have been made.
Madam Pele, do her stuff live.
Yeah.
Nice, gentle, fun volcano stuff.
Like if you learned something. Share if you think somebody else can learn something. Thanks for greatly appreciated. And we will see you guys next time. Bye.
Bye. See how wrong we are next time.
Yes, all of the wrong.